Hello, welcome to this video. Today we'll talk about distributed file system. This is the fourth chapter of the series, how to go from data to big data analytics. And today we will mainly be focused about file systems and how to store large data on distributed computers. So let's get started. Why do we need distributed file systems? We have many reasons. Just let's imagine we have a really large amount of data. We are like a big company and we have terabyte of data, and not just terabyte, like petabyte of data, for example. That's an amount of data that can't be stored on a single computer. So we need a way to save a huge amount of data, a large amount of data. And distributed file system offer a solution to this problem. We also need a way to compute over those distributed data. So maybe you have maybe a Facebook, I don't know, for example, and you have a lot of data. You want to make some inference on this data. You need a way to compute over the amount of data you saved in this distributed file system. So in this video, we'll talk about how to save this data. And in the next video, we'll talk about how to compute over a distributed data stored in a distributed file system. So I will first introduce by talking about the architecture. That's a broad view of the architecture before talking about the problem, defining some terms, and explaining some operations of our distributed storage. So the first view is that one. We have this really big file here. We have this big file. It supposes like 10 terabyte in. We cannot store it in a single computer. That's a fact. If it is a really large amount of data, we cannot store it in a single server. So what we do is like we divide this file into different single parts that we call chunk. I will define chunk in the next section. And we save each chunk in a specific server. So this file have different parts distributed over different servers. And we have specific way to read the file, to update the file, and to write the file to those different servers. And now we'll explain all those operations in the upcoming sections. So let's first start by defining what the problem is. With this architecture I just presented previously, we can first judge a huge amount of problem that we will face when saving a file with this architecture specifically. First, we will have this read problem. Like if you have this architecture here and we want to read a complete file, for example, how do we do? Because the file is kind of distributed over different servers. How do we kind of read the file? Do we get the first part from this server and get the second part? Do we kind of merge the file before sending it to the client? How do we read a file that is saved over the distributed system? With the read problem, we also have the update problem. Like, how do we update a file? If you want to add a line to the middle of the file, do we save it in one chunk that have the first part of this file or the second part? This is also one of the problems we have to face when we want to save a huge amount of file in a distributed file system. The third problem is the resilience problem. What happens if one computer dies with one part inside? Do we kind of lost the complete files because we will lost this part? So we need a solution to that problem also. How do we deal with this case? We also have the complexity of the, like, if you have DropBox, if we take, for example, DropBox or Google Drive, you are not supposed to know how they save your file over many servers. All you want to do is click on a file, read it, close, open a folder, create a folder. You are not supposed to understand all the complexity behind the system. So how do we, as a developer, hide this complexity to the end users? Okay, and lastly, we have this problem of performance and availability. How do we make sure that the system is always available? It means when one server dies, we make sure someone is always able to read the file completely. And how do we make sure that these operations are made as fast as possible? like how do we take care of the performance part in this system. And in the upcoming part, I will just introduce some operations that we kind of give a solution to the problem we are presenting here. So concerning the architecture itself, we need to understand some words before going into the operation. So those words are, for example, a node. What is a node? What is a node server? I introduced the node previously with the chunk. The node is actually just a server storing one part of the file, storing a chunk. I will define a chunk in the next part. So just consider a node as one computer in this distributed storage of computers, distributed network of computers. One node or a node server is one computer in this architecture. So what is a chunk? A chunk is actually a part of a file. This part is saved in a node server. So that's it. A chunk is just a small part, a small chunk of a file. And the chunk node is actually a node server storing a small chunk of a splitted file. What is a master node? I talked about the node server and the chunk server. If we split the file and save it in different node server, we need a place or a database or storing all the information about which file is where and which replica is where, but we'll talk about replica later. So the master node is actually the server that is responsible of storing all the metadata or informations about a chunk, and the server storing this chunk. Also keeping the information about which server is alive, which server is working, if your server is dead, and what to do when the server is dead. This is a master node kind of controlling all the other nodes. What is a replica and what is replication? Replication is just a process of getting one thing, duplicating the thing, or maybe in our case here, in different server. Like if you have a chunk, we want to replicate the chunk, we get the original chunk in one server and create the replica of this chunk in different other servers. It helps solve one of the problems we mentioned before, the problem of availability, and the problem of if one node dies, what do we do? So if you have the replica of this node somewhere else, all we have to do is to contact the replica server to get the replica of this file instead of accessing the original file on the server that's actually dead. So this is it for the notion that you may need to understand before going into the architecture itself. So let's go to the architecture directly. We will present two main operations here. We'll present the read operation and the write operation in a distributed file system. When we have this architecture, we need to find a way to split the file, to save them in different servers, and to keep track of each part of where each part is saved. So, and for that we need a specific architecture, and this architecture actually describes it well. We have this client application. If I have to define the client, for example, you using Google Drive, you are the client. Your browser is the client. And then this client application, I want to write some chunk in the given file, like the home/user/some file, for example, and you want to write this chunk 1. The process is this one. This client application contact the master node and say, I want to write chunk 1 in this file. And the master node have this record of each chunk for this file specifically. He has this record saying, for example, that chunk 1 is in C1 and C7. That's chunk node 1 here and chunk node 7 here, for example. And for each chunk, the master node knows exactly where it's saved. So the master node will just say, okay, this is where you can save the C1 and C7. This is a handle where you can save chunk 1. And the client application will contact those nodes, one of the nodes directly, and send the data to this node. The node will receive the data, completely download the data in locally. And when the data is completely downloaded, you will make sure that this data is kind of saved over the replica also. So you will kind of replicate this data over C7, for example. And when this replication is done, you can return a statue, for example. Maybe if there's a failure, we say, okay, I wasn't able to save it. And in that case, we cannot confirm to the client that the file has been saved. So what we do is that we try again until we are able to replicate the original data that we saved in C1 into C7. And when that's done, we receive the C1 receive a success statue. And this statue is actually sent to the client saying that, okay, everything was done successfully. The chunk you wanted to save is actually saved in C1 and C7, and the master node keep track of the right records containing the file itself and the replica. So that's the complete process of writing in a distributed file system. We'll see. So what about reading now? Reading is actually kind of the same thing as writing, but we don't have this replication phase in between. So what we do is like, the client say, I want to read this chunk 1, in this file. This master node know exactly where to find this file. So it sent back the response to the client, saying you can find in C1 or C7. And client will just ask to C1, for example, that I want this chunk 1 file, and it will send back the data. Just as easy as this, actually. So that's just the process. And what we do is like, we make sure, like, when you see this server is involved, here means they are the principal node server storing the file, or they are just replica. So when you want to contact the server to get a chunk of the file, you contact the principal server, and the replica are just here to save the file just in case one of the server died. So we can use the replica to replicate again and create this stable architecture that we have that can handle failures, and that is actually resilient and performant. With those two operations, we can actually create a complete and complex file system. And as example, I will just show you some example of a file system in the next part. We kind of have Google file system that I will show you the first architecture of Google file system. I think it's the one powering Google Drive. I will also show you picture of Hadoop distributed file system. Yes, of the architecture, so you can see the difference between those two. But let's talk about replication management. How do we deal with replication or replica? So we have a simple process. This process is as follows. The master node that we have here have to receive from each server a message saying I'm alive. I think there is a given amount of time, maybe let's say 1 minute. After 1 minute, each server have to send a message to the master node saying I'm alive. This is the I'm alive message that you can see here. I'm alive message. And after a given amount of time, if one server doesn't send this message, so if the master node receives any message from maybe chunk node 1 saying I'm alive, it will just mark this node as a failed node. That node is not in our network anymore. And the next process after that is actually to get the data that all the chunk that we saved on this C1, we have replica on other servers. We kind of replicate again because we need at least a certain amount of replica of each chunk to make sure the system is always available. So if, for example, we have, let's say, one chunk is in the one node and a replica in another node, the second node containing the chunk will actually replicate it to some given server that the master node just specified. And when the replication is done, you will send back a message to the master node saying that actually this chunk is actually saving me and this other server where the replication was successful. And in that way, we are sure that each chunk is actually saved with a replica in the whole system, and that if one node fails, we are able to reconstruct the whole file at any given moment. So, as I was saying, after the replication management, we'll just talk about some architecture of some well-known file system, like the Google file system. Here you can see it's kind of actually the same process I shown I showed in the last read process. Like you have this application, that's the client, that's the master node, that's the chunks nodes, and we just have these and get the handle, and you send the data to this chunk node, and this chunk node just replicate to this second node, and then maybe this is a read operation. Actually, I think so, because you just get the handle, you send it to the chunk node, and chunk node just send back the data. So that's a read process. So that's how the first version of the Google file system were actually supposed to work. So maybe in the meantime they kind of evolve or change some stuff, but this was the architecture. And we also have this open source and free distributed file system called Hadoop distributed file system. It is really easy to launch on your home computer or to launch on a network of computer if you want to play with it. I'll just put the link in the description, but I think in the blog post I explain how to do that. I'll put the link to the blog post in the description also. But here you can see that the main difference is that the master node is called the name node here, and it saves them actually the same thing. The metadata about replica and chunks, and we have the client here, and we have the data node. So instead of calling them the chunks node here, we call them the data node in our case here, and we have a replication operation going on between two data nodes. So that's actually a broad view about distributed file system. There are a lot more to discover about the topic. Hope this video was interesting for you. Hope you learned something new today, and thanks for watching, and see you in the next video. Bye.